functions. I'm going to start with the definition. So a function a of f from a set of A to a set of B is a relation that assigns to each element in A exactly one element in B. We have an example right here where X is a student or a person, and this is the candy bars, the output. So Carl is going to get Twix, Bob is going to get Twix, and Mike is going to get Almond Joy. This is an example of kids can only get one candy, but the candies can get more than one student. Like it's shown right here. So now we're gonna do some examples. We have example 1, x plus 3x equals f of x. We're gonna plug in for x3. So let me do that for you. X plus 3, and then plug in for 3 equals f of 3. So we solve for that. Let me get my calculator. So we basically put in the calculator 5 plus 3 times 3 and equals 14. So f of 3 will equal 14. That's example number 1. So kid 3 is going to get candy number 14. Now let me do example number 2. So we have x squared plus 2x minus 4 equals f of x. So we're going to plug in x equals 5. So let me do that. 5 squared plus 2. So we plug in for x minus 4 equals f of 5. So I put that in the calculator. You just put it right as it is. So 5 squared plus 2 times 5, it equals 35. So f of 5 equals 35. So kit 5 is going to get an output of 35.
We're going to be talking about graphing, and basically we have two equations here, and I'll prove why this is a function, I'll prove why that's not a function. So we have this thing called the vertical line test, and it's basically if you draw a line anywhere in this function, it will only, a vertical line anywhere on this function, it will only cross through one point. So we can go like that, and like it only touch at one point at any part of the function. But if we go on this one and make a vertical line, it will actually touch to 2 points. And it doesn't have to be just 2 points, it can be, as long as it's more than one, it will not be a function. And actually what's interesting about this one is that it has several zeros that I would like to talk about. Right here, sorry I forgot that one, and right there and right there, those are like special zeros, because that's the ones that intersect the x-axis. Intercepts are when y equals to 0, so that's why there's 2 of them, because you do your factoring and etc. And your y-intercept is when your x equals to 0. In this case, it's just negative 3. Today we're going to be talking about even and odd functions. This first function right here is an example of an even function because all the terms within it are raised to an even power. And this constant over here is 6 is actually x raised to the 0 power, but we don't write that because you know, it's just a given. So this is an even function. This one right here is an odd function because all the terms are raised to an odd power. Not to be confused with the 6, because sometimes people are confused with the leading coefficient. Like if the leading coefficient is even, they'll say it's neither, due to the fact, but the leading coefficient has nothing to do with it. Just remember that. And this one is neither actually, because it's this one's raised to an even power and this one's raised to an odd power. So that leads it to be neither. So if it's an even power, its graph is going to look like a parabola. But basically what we say is that it's reflected across the y-axis. And if it's an odd power, it's gonna be rotated around the origin. So if it's like right here, it'll be rotated 180 degrees around the origin. Okay, we're going to be talking about piecewise functions. And basically what a piecewise function is like you have your f of x, and then you have several equations that follow it, but turns out they use these equations when x meets a certain demand. So let's say, for example, we have x minus 3, and we're plugging it into this equation, and we go over here to our requirements, and it's if x is smaller than -2, we're going to use this equation, and it is. So we have an equation of f of -3 gives us -3 minus 2, and that equals -5. So let's say we have an x of 0, so that we would use this equation now, because it meets those certain demands. And so an f of 0 is going to equal just 4. Because you see there's no value of x, so it's just basically saying that every equation that means those certain demands, the answer is always going to be 4, which is a very neat thing that happens with piecewise functions. And our last value of x is going to be 4, and that means the demands of it being larger than 2. So we're going to use the final equation. So f of 4 is going to equal, and that equals 11. So